the edge of the solar system. Welcome. Get comfortable. Let your breathing slow. Tonight, we're to drift together through some of the most peaceful truths about our universe. Gentle facts that ask nothing of you except to listen and perhaps to fall asleep. We begin our journey at the edge. The very edge of the solar system. A place so distant, so quiet, that even light from our sun takes hours to arrive there. Imagine, if you will, a vast ring, a cosmic donut of ice and rock, spinning slowly in the darkness beyond Neptune. This is a Kuiper Belt, and it is immense beyond easy comprehension. The Kuiper Belt begins roughly 30 astronomical units from the Sun. 1 astronomical unit. That's the distance from Earth to the Sun, about 93 million miles. So 30 of these, then stretching outward to perhaps 55 astronomical units, maybe more. The boundaries are soft, uncertain, like fog at the edge of a forest. To put this in perspective, the asteroid belt between Mars and Jupiter, that band of rock we often hear about, it's tiny by comparison. The Kuiper Belt dwarfs it. It encircles the entire solar system like a great, patient halo. And yet, for all its size, the Kuiper Belt is mostly empty space, mostly darkness, mostly silence. The total mass of everything in the Kuiper Belt, every chunk of ice, every frozen rock, every dancing bit of dust, all of it together amounts to perhaps 1/10 of Earth's mass, maybe less. Some estimates suggest just 1/100th, such a vast region of space, and yet so little matter within it. It's humbling, isn't it? That something so enormous can contain so little. Within this region drift trillions of objects. Trillions, most of them small, most of them invisible to us. Dirty snowballs, essentially ice mixed with rock and carbon, tumbling slowly through the void. They've been there since the solar system formed 4.5 billion years ago. Patient witnesses to everything that has happened since. Most of these objects we will never see. They're too small, too distant, too dark. They reflect barely any sunlight. They simply exist out there, unbothered by observation. Some are larger, of course. Pluto is the most famous resident of the Kuiper Belt, along with its companions. Eris, Makemake, Haumea, worlds of ice with names borrowed from mythology. But even these are just the largest members of an incomprehensibly vast population. Beyond about 55 astronomical units from the Sun, something interesting happens. The dust begins to drop off. Particles become scarcer. The density thins even further than it already was. This isn't a sharp boundary. Nothing in space ever is, but rather a gradual thinning, a slow fade. This is where the Kuiper Belt transitions into something even more mysterious. The inner edge of the Oort cloud, a spherical shell of icy bodies that may extend nearly halfway to the nearest star. But that is a story for another time. For now, just rest with this image. The Kuiper Belt, a ring of ancient ice, 30 to 55 times farther from the sun than we are. a region larger than anything in the inner solar system, yet containing less mass than our single planet. Trillions of objects, most unseen, drifting, waiting, unchained for billions of years. It's still there right now, even as you close your eyes, spinning silently in the dark, peaceful, patient, eternal, the edge of our solar system, the beginning of the great beyond. Let that vastness hold you. Let it remind you how small our worries are, how brief our concerns. In the face of such scale, such time, such quiet endurance, the Kuiper Belt asks nothing of you. It simply exists. And so can you tonight, simply existing, simply breathing, simply drifting towards sleep. Out there, beyond Neptune, beyond the light, the ice tumbles on. And here, in your bed, in your room, you are safe. You are small. You are allowed to rest. Breathe in the darkness. Breathe out the day. The Kuiper Belt will still be there tomorrow, and the day after that, and a billion days after that. Such permanence, such peace. Let it carry you now, gently toward dreams. A brief history. We didn't even know it was there. It's remarkable, really, how recent our knowledge is. The Kuiper Belt, this enormous structure at the edge of our solar system. We didn't even know it existed until most of us were already alive. For most of human history, we thought the solar system simply ended at Neptune, discovered in 1846. Neptune was a final planet. Beyond it, nothing, just emptiness, just a long fall into interstellar space. But some scientists wondered. Some minds couldn't quite accept that the solar system would just stop. In 1943, an Irish astronomer named Kenneth Edgeworth published a paper. It was a quiet paper, not widely read at the time. In it, he suggested something curious. He proposed that beyond Neptune, there might be a region of small bodies, leftovers from the formation of the solar system, to spread out to have coalesced into a planet, but still there, orbiting, waiting. Few people paid attention. A few years later, in 1949, an astronomer named Frederick C. Leonard made a similar suggestion. He wondered aloud whether there might be a population of objects beyond the known planets. Again, the idea drifted past without much notice. It was speculation. Interesting, perhaps, but unprovable with the telescopes of the time. Then, in 1951, the Dutch-American astronomer Gerard Kuiper entered the story. Kuiper was prominent, well-respected. He wrote about the possibility of a belt of icy objects beyond Neptune, and because of his stature, his name stuck to the idea. The Kuiper Belt, named after Gerard Kuiper. But here's where it gets interesting. Here's the irony that would make you smile if you weren't already drifting towards sleep. Kuiper himself didn't actually believe in a stable, long-lasting belt. In his model, he argued that Pluto would have scattered or ejected most of these objects over time. He thought the belt would have been depleted, emptied, leaving almost nothing behind. So the Kuiper Belt is named after a man who argued it probably didn't exist in any substantial form. Strange, isn't it? How history works. How names attach themselves to ideas in unexpected ways. For decades, this remained theoretical, something to ponder, something to write papers about. But no one had seen anything out there. No telescope had found these hypothetical objects. Then came Voyager. Voyager 2, to be precise. In 1989, Voyager 2 flew past Neptune as it sailed beyond the last planet. Its instruments detected something subtle. Dust. A slight increase in dust grain impacts. Tiny particles, far from the sun, pinging against the spacecraft detectors. It wasn't proof. Not quite, but it was a whisper, a hint. Something was out there, grinding and colliding, creating dust where there shouldn't be any. Still, we needed more. We needed direct detection. We needed to actually see something. For years, astronomers searched. They pointed their telescopes beyond Neptune and looked, and found nothing. The Kuiper Belt, if it existed, was playing hide and seek in the darkness. Then on August 30th, 1992, everything changed. Two astronomers, David Jewett and Jane Liu, working at Mauna Kea Observatory in Hawaii, found something. A tiny point of light moving slowly against the background stars. Slow enough that it had to be distant. Slow enough that it had to be beyond Neptune. They designated it 1992 QB1. Not a poetic name. Not yet. Just a catalog designation. But it was real. It was there. The first confirmed Kuiper Belt object. After decades of speculation, after years of searching, humanity had finally seen the edge. One object doesn't prove a belt, of course. It could have been a fluke, an outlier, a single wanderer in the dark. But then they found another, and within a few years, dozens, then hundreds, then thousands. The floodgates had opened, or rather, our eyes had finally adjusted to the darkness. What emerged from these discoveries was different from what many had expected. The early hypotheses often spoke of a comet belt, a dense reservoir of comets waiting to fall inward. Some imagined it would be thick with objects, crowded, almost cluttered, but the reality was more subtle, more sparse. The Kuiper Belt, as we now understand it, is not densely packed. It's a sparse disk, vast distances separate most objects. You could spend a lifetime drifting through it, and likely never come close to anything at all. It's populated, yes, but the population is spread thin across an almost incomprehensible volume of space. This was a shift in understanding, from the idea of a crowded belt to the reality of a sparse distribution, from thinking of it as a wall of objects to understanding it as a whisper matter across enormous distances. And all of this knowledge came to us so recently, 1992. That's when we truly confirmed the Kuiper Belt's existence, not in some distant past, not in the age of ancient astronomy, but just over 30 years ago. Some of you listening tonight were already adults when we discovered it. Some of you were children. Some of you weren't born yet. But none of you are very old when measured against this discovery. It's humbling in a gentle way to realize how new our knowledge is, how recently we learned about this fundamental structure of our own solar system. For all of human history, until 1992, every human who ever lived before that moment, they didn't know the Kuiper Belt was there. They looked up at the night sky and saw Neptune as the edge, the end, the final marker. And they were wrong, not through any fault of their own. They simply didn't have the tools yet. The universe was keeping a secret. And then, one night in August, the secret was revealed. A tiny point of light on a photographic plate. 1992 QB1. The first glimpse of something vast and ancient that had been there all along, patient, waiting to be noticed. Since then, we've found thousands more. We've mapped the region. We've sent new horizons to fly through it, giving us our first close-up views of these distant worlds. But it all started with that one detection, that one moment of confirmation. The Kuiper Belt is real. It's there. And now we know. Such a simple statement. Such a profound shift in understanding. So rest now, knowing that the universe still holds secrets. That even in our own solar system, in our own cosmic backyard, there are things we've only just begun to understand. The Kuiper Belt waited 4.5 billion years to be discovered. It can wait a little longer while you sleep. Close your eyes. Let the history wash over you. Let the recent nature of this knowledge remind you that discovery is always possible. That tomorrow might bring new light to old darkness. Somewhere out there, beyond Neptune, 1992 QB1 is still orbiting, still tumbling through the void, still being itself, as it has been for eons. And here, you can simply be yourself too. No discoveries required. No searching needed. Just rest. Just breathe. Just drift. The edge of the solar system is patient, and so is sleep. Let it come. Birth of a relic. A time capsule from 4.6 billion years ago. Let's go back now. Far back. Further than history. Further than humanity. Further than Earth itself in its current form. 4.6 billion years ago. The solar system is being born. There is no sun yet. Not quite. Instead, there's a vast cloud of gas and dust, slowly rotating in the darkness between stars. Hydrogen, helium, and a sprinkling of heavier elements, carbon, nitrogen, oxygen, iron, all the debris of previous stellar generations, now gathering together. Gravity pulls. The cloud collapses. At its center, material falls inward, compressing, heating. The pressure builds. The temperature rises. And eventually, ignition. The sun begins to shine. But most of the cloud doesn't fall into the sun. Most of it spreads out into a disk, a flat, spinning disk of dust and gas, extending billions of miles outward from a newborn star. This is the protoplanetary disk, the birthplace of worlds. Within this disk, dust grains begin to stick together. Tiny collisions, electrostatic forces, sticky ices. Grain by grain, they grow pebbles, rocks, boulders, planetesimals, objects the size of mountains, the size of cities, closer to the sun, where it's warm. These planetesimals are mostly rock and metal. Further out, where it's cold, they're rich in ice. Water ice, methane ice, ammonia ice, frozen volatiles that would evaporate near the sun, but remain solid in the outer darkness. These planetesimals continue to collide, continue to grow. In the inner disk, they become Mercury, Venus, Earth, and Mars. In the outer disk, they form the cores of Jupiter, Saturn, Uranus, and Neptune. But beyond Neptune, something different happens. Out there, in the far reaches of the disk, there simply isn't enough material. The density is too low. The planetesimals are too spread out. They collide less frequently. They grow more slowly. And before they can gather into anything planet-sized, before they can complete their assembly, the process is interrupted by Neptune. As the giant planets form, they interact with the remaining gas in the disk. These interactions cause them to migrate, to drift. Jupiter may have moved inward slightly, then outward. Saturn certainly shifted. And Neptune moved outward significantly. Picture it now, if you can. Neptune, a massive world of ice and gas, plowing outward to the disk of planetesimals, scattering them, flinging them. Some are thrown inward toward the sun. Some are ejected entirely, sent tumbling into interstellar space. Some are captured into resonant orbits, locked in gravitational step with Neptune itself. And some remain, too far to be completely disrupted, too numerous to all be scattered. They settle into a new configuration, a depleted configuration, a sparse belt of survivors. This is the Kuiper Belt, not a failed planet, not something that tried to form and couldn't, but rather a relic, a leftover, a population of planetesimals that never got the chance to complete their growth. They were interrupted, frozen in time, almost literally at an early stage of planetary formation. And there they remain even now for 0.6 billion years later, essentially unchanged. Think about that for a moment. Unchanged for 4.6 billion years. During that time on Earth, single-celled life arose. Photosynthesis evolved. Oxygen filled the atmosphere. Complex life emerged. Animals appeared. Plants colonized the land. Dinosaurs rose and fell. Ice ages came and went. Our species appeared, spread across the planet, built civilizations, invented writing, mathematics, science. And the entire time, every moment of every day of every year of all that history, the Kuiper Belt was just there, orbiting, unchanged, waiting. Not all of it is pristine, of course. Neptune's migration stirred things up, scattered populations, heated and excited orbits. The dynamical structure of the Kuiper Belt is complex, shaped by billions of years of gravitational influence from the giant planets. But there's a region called the cold classical Kuiper Belt. Cold, meaning the orbits are not highly eccentric or inclined. Classical, meaning they're in a region where we'd expect the original disk to be, undisturbed by resonances with Neptune. These objects, these cold classical objects, they're the most pristine of all. They likely remain in nearly the same orbits they formed in. They've experienced minimal heating, minimal collision, minimal change. They are, as closely as we can find anywhere, fragments of the original protoplanetary disk, time capsules, messages from the beginning. When we study these objects, we're not looking at something modern, something evolved, something processed. We're looking at the raw materials of planet formation, the building blocks, the ingredients that, in other parts of the solar system, went into making worlds. But here, they remain separate, individual, frozen. The surfaces of these objects contain something remarkable. Organic compounds, not life, but complex carbon-based molecules. Tholins, we call them, a word from Greek meaning muddy or murky, because they give these objects their reddish-brown color. These tholins form when simpler molecules, methane, nitrogen, carbon monoxide, are exposed to radiation over vast periods of time. Cosmic rays, ultraviolet light from distant stars. The radiation slowly, patiently, rearranges the molecules into longer chains, more complex structures. On Earth, such organics would be destroyed or transformed, heated, oxidized, weathered, consumed by life, incorporated into biology, and recycled endlessly. But in the Kuiper Belt, they simply accumulate, layer upon layer, for billions of years, preserving chemistry from the very formation of the solar system, perhaps even from before pre-solar grains inherited from the molecular cloud that collapsed to form our sun. This is why scientists care so deeply about the Kuiper Belt, why we send spacecraft there, why we study it with such attention. It's not just interesting, it's precious. It's the only place we can still touch the beginning, the only repository of largely unaltered material from the epoch of planet formation. Every asteroid we've studied has been heated at least a little. Every comet that enters the inner solar system gets baked by the sun. Every planet has been melted and differentiated, its materials sorted by density and chemistry. But the cold classical Kuiper Belt, it's still original, still waiting to tell us what the solar system was made from, what conditions were like at the beginning, what chemistry was present before planets altered everything. When New Horizons flew past Arrokoth in 2019, it revealed a world unlike anything we'd seen before. Two lobes gently merged together. No signs of violent collision. Just a slow, gentle accumulation, a contact binary formed from a cloud of pebbles that gradually collapsed under their own weak gravity. This is what gentle formation looks like. This is what happens when planet building proceeds without disruption. And Arakoth has been that shape ever since. 4.5 billion years, tumbling slowly through the dark, preserving its formation story in its very structure. Resting now, let this timeline wash over you for 0.6 billion years. An almost meaningless span of time to our brief human minds. And yet, the Kuiper Belt has endured it, has remained, has waited. You are made of atoms forged in stars, and those stars exploded and their debris drifted, and some of it became the cloud that formed our solar system. Some of it became you. Some of it became the Kuiper Belt. You and those distant icy worlds. You share an origin. You're both children of the same stellar nursery. You're both 4.6 billion years old. In a sense, your atoms are, at least, but while you've been through the chaos of planetary geology and biology and evolution, while you've been recycled countless times through rock and water and life, those distant objects have simply been quietly existing, patiently orbiting, preserving the memory of the beginning. There's something peaceful in that thought, something restful. The universe remembers. Even when everything changes, even when worlds are born and life emerges and civilizations rise, somewhere, somehow, the original materials are preserved. The memory remains. The Kuiper Belt is that memory. Ancient, precious, unchanged, and it will remain there long after we're gone. Long after Earth is gone. Long after the sun swells into a red giant and consumes the inner planets. Those distant icy time capsules will still be there, still orbiting, still carrying their message from the dawn of the solar system. So sleep now, knowing that the past is preserved, that the beginning is still out there, waiting, that some things do last, essentially forever, in the patient darkness of space. You don't have to last forever. You just have to rest tonight. The Kuiper Belt will keep watch, as it has for billions of years, as it will for billions more. Breathe deeply. Let the vastness of time hold you. Let the ancient ice comfort you. You are safe. You are small. You are allowed to sleep. The time capsule keeps its vigil. And you can simply drift away into dreams, into rest, into the gentle darkness. The beginning is still there, waiting, and so is tomorrow. But for now, only sleep. The architecture, not just one simple ring. When we first imagined the Kuiper Belt, we pictured something simple. A ring, a band of objects, all orbiting more or less together, more or less the same way. Neat, organized, easy to understand. But the universe is rarely that simple. And the more we looked, the more we discovered, the more we realized that the Kuiper Belt isn't one thing at all. It's many things, many populations, many families of objects, each with their own story, their own origin, their own relationship with the architecture of the solar system. It has structure, hidden structure, order within apparent chaos. Let's explore this architecture together now. Gently, without rushing, let the complexity wash over you like waves, repeating patterns that eventually become soothing simply through their rhythm. First, there are the classical Kuiper Belt objects. These are the ones we think of as the true belt, objects orbiting roughly where we'd expect the original protoplanetary disk to be, not in resonance with Neptune, not on highly eccentric orbits, just there, orbiting peacefully between about 42 and 48 astronomical units from the Sun. But even within this classical population, there's a division. There are cold classical objects and hot classical objects. Now, these names are misleading. They don't refer to temperature. Everything in the Kuiper Belt is frozen. Everything is cold in the way we usually mean the word. Temperatures hovering around minus 230 degrees Celsius. So cold that nitrogen freezes solid. So cold that even methane becomes ice. No, cold and hot here refer to orbital properties, specifically inclination. Cold classical objects have low inclination orbits. They move around the Sun in nearly the same plane as the planets. Their orbits are circular or close to it. They're dynamically calm, unperturbed. These are probably the most pristine objects in the entire Kuiper Belt, the ones that have been least disturbed since formation. Hot classical objects, on the other hand, have higher inclinations. Their orbits are tilted, more eccentric, more stirred up. They're still in the classical region, still not in resonance with Neptune, but they've been excited, disturbed, possibly by Neptune's migration, possibly by something else we don't yet understand. Two populations, same region, different histories. Then there are the resonant populations. Resonances are beautiful things. Gravitational resonances, orbital resonances, places where an object orbital period relates to Neptune's period in a simple ratio. 3 to 2, 1 to 2, 5 to 2. The most famous resonant population is the 3 to 2 resonance. For every 3 orbits Neptune makes around the Sun, objects in this resonance make exactly 2 orbits. They're locked in step with Neptune, dancing with it, never getting too close, never drifting too far. We call these objects Plutinos, named after Pluto, the most famous member of this population. Pluto orbits in the 3 to 2 resonance with Neptune, always has, always will, for as long as the current architecture of the solar system persists. And Pluto isn't alone there. Thousands of objects share this resonance. Thousands of Plutinos, all marching in gravitational lockstep with Neptune. Then there's the 1 to 2 resonance. Tutinos. For every 1 orbit of Neptune, they make 2. They're closer in, around about 47.7 astronomical units, but still held in Neptune's gravitational grasp, and the 5 to 2 resonance. And others, Each resonance is a stable haven, a place where orbits can persist for billions of years, protected from chaos by the very regularity of the gravitational dance. Between the resonances, gaps, not empty, exactly. Nothing in space is truly empty, but depleted, less populated. Places where orbits are unstable, where objects gradually get perturbed away, either into resonances or into other regions entirely. These gaps and resonances create structure, a rhythm, an architecture. The Kuiper Belt isn't a smooth distribution of objects. It's quantized, almost, clumped into resonances, separated by gaps, organized by Neptune's gravity into a pattern we're still learning to read. There's even something called the kernel, a concentration of objects around 44 astronomical units, a slight overdensity, not a dramatic clump, but a subtle enhancement, as if that distance has some special significance in the architecture of the belt. And recently, very recently, some researchers have suggested there might be an inner kernel as well, around 43 astronomical units. Another subtle concentration, another hint of structure. Why there? What makes these distances special? We're not entirely sure yet. It might relate to the details of how Neptune migrated, where it paused, perhaps where its influence was strongest or weakest during certain epochs. The Kuiper Belt remembers Neptune's journey. It's written in the distribution of orbits. Then there's the scattered disk. These objects are wild, highly eccentric orbits. Perihelia, their closest approaches to the Sun, that bring them near Neptune. Aphelia, their farthest points, that carry them hundreds of astronomical units outward, deep into the realm where the Oort cloud begins. These objects were scattered by Neptune, flung outward by close gravitational encounters. They're not in stable resonances. They're not in the classical belt. They're elsewhere, passing through, visiting. Some will eventually be ejected entirely. Some will settle into more stable orbits. They're in transition, between worlds, between populations. Eris, one of the largest known dwarf planets, is in the scattered disk. So is Sedna, that strange distant world with an orbit so eccentric it suggests gravitational influences we don't yet understand. The scattered disk blurs the boundary between the Kuiper Belt and the Oort cloud. It's the transitional zone, the gradient, the place where one population fades into another. And beyond all of this, there are hints, tantalizing hints, of something more. Some observations suggest there might be a second Kuiper Belt-like ring, farther out, beyond the main belt. Another population of objects, detached from Neptune's direct influence, orbiting in their own distant realm. We haven't confirmed this yet. The evidence is subtle, but it's there, whispering, suggesting the solar system might be even more structured than we thought, even more layered, rings within rings, populations within populations, architecture all the way out. Think about it now as you rest. this order, this structure, these resonances and kernels and populations. It's not random. It's not chaos. Even though it formed from a cloud of gas and dust, even though it was shaped by migration and scattering and billions of years of gravitational interactions, there's pattern, there's rhythm. The universe tends towards structure. Gravity creates order, simple laws, acting over vast timescales, produce architecture, 3-2 resonance, 1-2 resonance, cold classical, hot classical, scattered disk, kernels at specific distances. Each object knows where it belongs. Each orbit is part of a larger pattern. You don't have to understand it fully. You don't have to remember the numbers or the names. Just rest in the knowledge that it exists. That even at the edge of the solar system, there is order, hidden order, subtle structure. The Kuiper Belt is not one simple ring. It's a symphony, multiple movements, multiple themes, all playing together in gravitational harmony. And it will keep playing long after you've fallen asleep, long after you've woken tomorrow, long after your life and mine. The architecture persists, the resonances hold, the structure endures. So let yourself be held to by the structure of your bed, by the rhythm of your breathing, by the gentle pull of sleep. You are also part of an architecture, part of a pattern, part of a structure much larger than yourself. And for tonight, your only job is to rest within it. The Kuiper Belt orbits on. The resonances hold. The kernels persist at their appointed distances. And you can simply let go. Let the architecture of the universe hold you. Let the pattern continue without your attention. Let sleep come as it always does in its own time, following its own rhythm. Everything is in its place, including you. Close your eyes. Trust the structure. Drift into the darkness. The belt revolves. The resonances resonate. And you are allowed to rest. The inhabitants, worlds in the deep freeze. The Kuiper Belt is not empty. It is not a void. It is populated, inhabited by worlds, frozen worlds, each with its own character, its own story, its own peculiar beauty. These are not planets in the traditional sense. Most are smaller. Most orbit in ways that don't fit the formal definition. We call them dwarf planets, trans-Neptunian objects, Kuiper Belt objects, but they are worlds nonetheless. And tonight we'll visit them, gently, one by one. Let their names wash over you like a lullaby. Let their strangeness soothe you. We begin with the most famous, Pluto. For 76 years, Pluto was considered the ninth planet, discovered in 1930 by Clyde Tombaugh, a young astronomer in Arizona who patiently compared photographic plates, looking for something that moved against the background stars. And there it was, Pluto, tiny, distant, mysterious. When New Horizons flew past in 2015, it revealed a world no one expected. Not a dead, cratered ball of ice, but a geologically active world with towering mountains, flowing glaciers, and a surface that looked young. There's a region on Pluto shaped like a heart. We call it Tombaugh Regio, after Pluto's discoverer. And within that heart is a vast plain of nitrogen ice called Sputnik Planitia. This plain is smooth, remarkably smooth, no craters, which means it's young, geologically recent. The ice there is flowing, convecting, renewing itself even now. Cells of ice, each the size of cities, slowly churning like a lava lamp in extreme slow motion, on a world so far from the sun, so starved of heat, we didn't expect activity. We expected death, frozenness, stillness. But Pluto is alive, in its own slow, icy way, moving outward now, past Pluto, to Eris. Eris is slightly smaller than Pluto, but more massive, denser, and extraordinarily bright. One of the most reflective objects in the entire solar system. Its surface is coated in fresh methane frost. Methane that condenses from its thin atmosphere when Eris is farthest from the sun, creating a pristine white coating that reflects nearly all the sunlight that touches it. Eris is distant, very distant. Its orbit carries it as far as 97 astronomical units from the sun. Right now, it's about 96 astronomical units away, so far that the sun appears as nothing more than a very bright star. But even in that deep cold, methane cycles between ice and vapor. Seasons happen. Atmospheres condense and sublime. Change persists even at the edge. Now to Haumea. Haumea is strange, wonderfully strange. It spins fast, faster than any other large object in the solar system. One rotation every 4 hours. This rapid spin has stretched it, deformed it. Haumea isn't spherical. It's shaped like an elongated egg, like a cosmic football, and it has a ring, a thin ring of debris, orbiting around its equator, the only known ring system around a dwarf planet. It also has moons, 2 of them, Hyakka and Namaka, and beyond these moons, scattered to the Kuiper Belt, there's an entire family of objects with similar compositions, similar colors, similar orbits. The Haumea family. These objects are fragments, pieces of Haumea itself, blasted off by some ancient collision, a collision so violent it set Haumea spinning and sent chunks of its icy mantle flying into space, where they now orbit the sun as independent objects, carrying the memory of that long-ago impact onto Makemake. Makemake is covered in methane and ethane ices. These give it a warm, reddish tint, and it might have a thin atmosphere, seasonal, present only when Makemake is closest to the sun, when enough warmth arrives to sublime some of that frozen methane into vapor, an atmosphere that comes and goes, a world that breathes in its own slow rhythm once every 300 years as it completes its orbit. Quaoar follows a similar pattern. Quaoar also has methane ice on its surface, and also might have a very thin atmosphere, just a wisp, a suggestion of vapor above the ice. But Quaoar has something else. A moon named Waywat, and together they orbit a binary system, dancing through the darkness. Then there's Orcus and its moon Vant. Orcus and Vant are almost a double dwarf planet. Vant is large compared to Orcus, not quite half its size, but substantial. They orbit close together, locked in mutual gravitational embrace. How did they form? Did they accrete together, born as twins? Or did they collide and merge partway, becoming a contact binary that later separated? Or was Vant captured, grabbed by Orcus's gravity after forming elsewhere? We don't know yet, but they're there, together, orbiting together, possibly for billions of years. Moving on to Gong Gong. Gong Gong is blue, a deep, striking blue, one of the bluest objects in the Kuiper Belt. This color comes from methane and ethane ices on its surface. These ices absorb red light preferentially, reflecting back blue. So when we look at Gong Gong, we see blue, the color of frozen gases, the color of chemistry happening in the deep cold. And there are more, so many more. Salacia, a binary system where both components are roughly the same size. True twins. Verna, elongated, possibly from rapid rotation. Another stretch world. 2002 MS4. One of the largest objects in the classical Kuiper Belt. Its surface shows signs of crystalline ice. Ice that's been altered, organized, perhaps by internal heat long ago, when radioactive decay in its core could still warm the ice slightly. Each of these worlds has chemistry, surface composition. Methane here, nitrogen there, ethane, ammonia, water ice, carbon dioxide, tholins, a diversity of frozen materials, all existing at temperatures where everything we think of as fluid becomes solid, where air becomes ice, where oceans would be rock hard. And yet, diversity persists, color variations, compositional differences. Some worlds are bright, some dark, some red, some blue, some white, some have moons, some have rings, some spin fast, some slow. The Kuiper Belt is not uniform. It's a collection, a gallery, a museum of frozen worlds, each one unique, each one preserving some aspect of solar system history in its composition, its orbit, its moons, its surface. These are not just rocks, not just ice balls. They are worlds, small worlds, yes, distant worlds, frozen worlds, but worlds nonetheless. Each one has been there for billions of years. Each one has witnessed the entire history of the solar system from its distant vantage point. Each one knows things we're only beginning to learn. As you rest now, imagine them. Pluto with its nitrogen heart, Eris in its brilliant frost, Haumea spinning wildly, egg-shaped, ringed, Make with its seasonal atmosphere, Quaoar and Waywat orbiting together, Orcus and Vant, companions in the dark, Gong Gong strikingly blue. They're all out there right now, orbiting, existing, being themselves. They don't need us to watch them. They don't require our attention. They simply are. And there's something peaceful in that, something restful. The universe is full of things that exist without our knowledge or care. Worlds that spin in the darkness, covered in exotic ices, harboring their own slow processes, their own subtle changes. They were there before you were born. They'll be there after you're gone. And tonight, while you sleep, they'll continue their patient orbits, reflecting starlight from their frozen surfaces, maintaining their gravitational dances with their moons and rings. You don't have to do anything. You don't have to achieve anything. You can simply exist like these distant worlds. Simply be, simply rest. The dwarf planets of the Kuiper Belt ask nothing of you. They expect nothing. They judge nothing. They just orbit and shine and slowly, imperceptibly evolve. Let them be your companions tonight. Let their distant presence comfort you. Somewhere out there, Pluto's nitrogen glaciers are flowing. Eris's methane is condensing. Haumea is spinning. Make's atmosphere is there or not there, depending on the season. And here you are breathing, resting, drifting towards sleep. Both are valid ways to exist. Both are enough. The inhabitants of the deep freeze don't strive. Don't worry. Don't rush. They simply endure. Simply continue. Simply are. And tonight, so can you. Close your eyes. Let the frozen worlds orbit in your imagination. Let their names become a rhythm. Pluto, Eris, Haumea, Make, Quawar, Orcus, Gong, a litany of distant places, a prayer to the outer darkness. All of them still there, all of them still spinning, all of them still frozen, still at peace. And so, can you be? Rest now. The worlds in the deep freeze keep their vigil. You are allowed to sleep. Small bodies, strange shapes, snowmen, twins, and triples. Not all the inhabitants of the Kuiper Belt are large. Most, in fact, are small bodies, modest worlds. Objects just tens or hundreds of kilometers across. And many of them have the strangest shapes. On New Year's Day, 2019, the New Horizons spacecraft flew past an object officially designated 2014 MU-69. But we know it better by its nickname, Arrokoth. Arrokoth is small, only about 36 kilometers at its longest. A tiny world by any measure. And it looks like a snowman. Two lobes, one larger, one smaller, gently connected, a contact binary. Two objects that came together and stuck, forming one oddly shaped world. But here's what's remarkable. Here's what makes Arrokoth so scientifically precious. The two lobes didn't smash together. They didn't collide violently. There's no crater at the point where they meet. No signs of impact. No compression. No shattered rock. Instead, they just touched, kissed, merged gently. This tells us something profound about how Arrokoth formed, about how many Kuiper Belt objects formed. Arrokoth began as a cloud of pebbles, small particles orbiting the sun in nearly identical orbits, moving at nearly identical speeds, so close in velocity that when they encounter each other, they barely touched, barely bumped. Slowly, over time, gravity drew them together. The cloud contracted, collapsed, not violently, not dramatically, just gently, pebbles settling together like snowflakes, sticking where they touched. Eventually, the cloud separated into two concentrations, two forming objects, each growing in its own gentle way. And then slowly, these two objects spiraled together, drawn by their mutual gravity, until they touched. And there they've stayed ever since. For 4.5 billion years. Two lobes, connected, a snowman in the darkness. This is not how planets formed in the inner solar system. Earth wasn't built gently. Earth grew through violent collisions, planetesimals smashing together at kilometers per second, impacts so energetic they melted rock. The moon itself was born from a collision so tremendous it nearly destroyed the proto-Earth. Violence, heat, chaos. But out in the Kuiper Belt, things were different, quieter. The velocities were lower, the collisions gentler. Formation proceeded at a whisper rather than a shout. And Arrokoth preserves that gentle origin. Its very shape is a record of quiet assembly. It's not alone. Binaries are common in the Kuiper Belt, surprisingly common. Among small Kuiper Belt objects, a large fraction, perhaps 20 or 30%, are binaries, two objects orbiting each other, gravitationally bound twins. Some are contact binaries like Arrokoth, two lobes touching. Others are separated binaries, two distinct objects orbiting around their common center of mass, never touching but forever connected. Why so many binaries? Why is this configuration so common? Partly, it's because of where they are. The cold classical Kuiper Belt. Remember that region? Low inclinations, circular orbits, minimal perturbation. In that quiet region, binaries can survive. They're not torn apart by close encounters with planets. They're not disrupted by high-velocity collisions. They just persist. A binary that formed 4.5 billion years ago can still be a binary today, still orbiting, still connected in the inner solar system or even in the asteroid belt. Such binaries would be rare, disrupted, broken apart. But out in the cold classical belt, they endure. And their existence tells us that formation was gentle enough for two separate objects to remain gravitationally bound, to orbit each other without merging, to dance together for eons. Some systems go beyond binaries. Algyra, for instance, Algyra is a triple system, three objects orbiting together, gravitationally bound. A family. How do three objects end up together? How does such a delicate configuration survive? It requires very specific conditions, low velocities, gentle dynamics, minimal disruption, the kind of environment that only exists in the quietest regions of the solar system. Algira and its companions have been together for billions of years. 3 objects, maintaining their gravitational dance, orbiting in the outer darkness. It's almost poetic, almost beautiful. These shapes, these configurations, contact binaries, separated binaries, triple systems, they're all evidence of the same thing: gentle formation, quiet accretion, pebbles settling together under their own weak gravity, building worlds not through violence but through patience. This challenges our earlier assumptions. For a long time, planetary scientists assumed all solar system formation was violent. High-energy collisions, catastrophic impacts, chaos gradually organizing into order. But the Kuiper Belt whispers a different story. It says that sometimes, in some places, formation can be gentle, quiet, almost tender. Pebbles drifting together, clouds contracting, objects touching and sticking rather than smashing and shattering. And these gentle formations survive, persist, endure for billions of years, carrying the memory of their peaceful origins in their very shapes. Arakatha's 2 lobes, the high fraction of binaries, triple systems like Algira, all of them are messages from the past. All of them say, formation here was different, calmer, softer. The universe is not always violent. Even in the story of planetary formation, even in the chaos of the early solar system, there were quiet corners, peaceful regions, places where things came together gently. Rest with that thought now. Not everything is forged in fire. Not everything requires violence to exist. Sometimes things come together softly. 2 pebbles touching, 2 objects orbiting, 3 companions finding each other in the darkness. And they stay together for billions of years, not because they're forced to, not because they're trapped, but because their gentle beginnings set them on a path of peaceful coexistence. There's a lesson there if you want to find it, but you don't have to. You can just rest with the image. Arakath, snowman shaped, 2 lobes, gently merged, binaries throughout the cold classical belt, twins orbiting together, Algira and its companions, 3 objects, a family, all of them formed quietly, all of them survived, all of them still there, still together, still orbiting in the deep freeze. You don't need violence to create something lasting. You don't need catastrophe to build something beautiful. Sometimes gentle is enough. Sometimes soft endures better than hard. Sometimes the quiet things outlast the loud ones. The Kuiper Belt knows this, has known it for 4.5 billion years. And tonight, you can know it too. Let the gentle formation soothe you. Let the image of pebbles settling together calm your mind. You don't have to collide with tomorrow. You don't have to impact your problems at high velocity. You can approach things gently. Touch softly, build slowly, like Arakoth, like the binaries, like Algira's triple system, gentle formation, quiet persistence, soft endurance. These are valid strategies. These work. The cold classical Kuiper Belt proves it. The shapes prove it. The binaries prove it. Gentleness survives. So rest gently now. Settle into sleep like pebbles settling together. No violence. No impact. Just a slow, peaceful collapse into rest. Let gravity do the work. Let time take care of the details. You just have to be present. Be soft. Be willing to touch gently and stay. Like Arakotha's lobes. Like binary companions. Like Algira's family. Together, gently, forever. Close your eyes. Feel yourself settling. Contracting softly into sleep. This is your gentle formation, your quiet accretion. And when you wake, you'll still be together, still yourself, still whole, because gentle things endure. The Kuiper Belt has shown us this, and now you can sleep knowing it, softly, gently, peacefully, like snowflakes settling, like pebbles touching, like clouds contracting in the dark. Rest now. The gentle formation continues in the Kuiper Belt, and in you, sleep, active, not dead. These worlds still change. There's a common assumption about the Kuiper Belt, an easy mistake to make. People hear frozen and distant and ancient, and they think dead, static, unchanging, worlds where nothing has happened for billions of years. But that's not true. Not true at all. The Kuiper Belt is active, even now, even in the deep cold. Even at temperatures where nitrogen and methane freeze solid. Change still happens. Processes still run. These worlds are not dead. They're just slow. Let's start with the simplest process, the most fundamental, sublimation. On Earth, we're familiar with water cycling through different states. Liquid in the oceans, solid in ice caps and glaciers, vapor in the atmosphere, the water cycle, evaporation, condensation, rain, snow. In the Kuiper Belt, other substances cycle the same way, but at much lower temperatures. Nitrogen, methane, carbon monoxide. On Earth, these are gases, always gases, except under extreme conditions. But in the Kuiper Belt, they freeze. They become ices, solid nitrogen, solid methane, and yet they still sublime, still evaporate, still cycle between solid and vapor. When a Kuiper Belt object is at perihelion, its closest approach to the sun, it receives slightly more sunlight, just a little more heat, and that tiny increase is enough for some of the volatile ices to sublime, to turn directly from solid to vapor without melting first. This creates a thin atmosphere, temporary, seasonal, a few molecules of nitrogen or methane floating above the frozen surface. Then, As the object moves away from the sun again, back toward aphelion, the temperature drops, the vapor refreezes, condenses back onto the surface as fresh frost. This happens on Pluto. We know because New Horizons saw evidence of it. Fresh nitrogen ice, recently deposited. Pluto's atmosphere waxes and wanes over its 248-year orbit. Right now, Pluto is moving away from the sun. Its atmosphere is gradually freezing out, condensing, falling as nitrogen snow. By the time Pluto reaches aphelion again, most of its atmosphere will be frozen onto the surface, and there will stay as ice until Pluto swings back toward the sun decades from now. This same process happens on other large Kuiper Belt objects. Eris, Makemake, Quaoar, each with its own seasonal cycle, each with volatile subliming and refreezing in response to the tiny variations in sunlight they receive. Its weather, slow weather, seasonal weather measured in centuries rather than months, but weather nonetheless. Change, ongoing, active. Now consider something stranger. Cryovolcanism. Volcanism, but cold, not molten rock, but molten ice, water ice mixed with ammonia, perhaps, or other substances that melt at low temperatures. We've seen evidence of cryovolcanism on some Kuiper Belt objects. Ammonia frost on surfaces. Ammonia shouldn't be there. It's volatile. It should have been lost long ago, evaporated into space or destroyed by radiation. Unless it came from below, from the interior, erupted, brought to the surface by some form of icy volcanism. Internal heat, still present, still driving processes. Even 4.5 billion years after formation, where does this heat come from? Partly from radioactive decay. Certain isotopes, potassium-40, uranium-238, thorium-232, decay slowly over billions of years, releasing heat. Not much heat, but in the insulated interior of an icy world, even a little heat can accumulate, and partly from tidal heating in some cases. If a Kuiper Belt object has a large moon, close enough to raise tides in its interior, the flexing and friction can generate warmth. Enough warmth, perhaps, to melt ammonia-water mixtures, to drive them upward through cracks, to erupt them onto the surface as cold, slushy flows. Cryovolcanism, ice volcanoes, active geology at -200 degrees. The universe finds ways. Impacts, too, continue to shape these worlds. We found fresh craters on Pluto, young craters, formed recently in geological terms, within the last few 100 million years, perhaps even more recently. And on Arikov, close examination revealed small impacts, tiny craters, evidence that even in the sparse Kuiper Belt, collisions still happen occasionally. Objects still strike each other, still transfer energy, still reshape surfaces. Not often. The Kuiper Belt is not crowded. You could spend millennia drifting through it without ever coming close to another object, but occasionally, rarely impacts occur, and when they do, they create craters, eject material, expose fresh ice from beneath the surface. Change, sudden change, punctuating the slow seasonal cycles. There are resurfacing processes too. On Pluto's Sputnik Planitia, the nitrogen ice flows. Convex slowly churns, driven by temperature differences within the ice itself. Warmer ice rises, cooler ice sinks. The surface renews itself, erasing craters, creating that smooth, young appearance. This is happening now, today, tonight, as you listen. Pluto's nitrogen heart is flowing, slowly, imperceptibly to us, but measurably, actively, and there's color diversity, such striking color diversity. Some Kuiper Belt objects are red, deep red, orange red, the color of rust, of clay, of autumn leaves. Others are neutral, gray, almost white. Why the difference? The red objects have organic materials on their surfaces. Tholins, complex molecules built up over billions of years from simpler ices exposed to radiation. These tholins absorb blue light and reflect red, giving the objects their distinctive color. But some objects don't have this red coating. They're gray, neutral. Why? Perhaps they've been resurfaced recently. An impact exposed fresh ice from below. Cryovolcanism brought clean material up, or collisional chips knocked off the red coating, revealing pristine ice underneath. Color tells us about surface age, about processes, about whether an object has been changed recently or has sat undisturbed. Arikov, for instance, has reddish areas, particularly on its neck, where the two lobes meet. The red color there seems to come from methanol. Simple methanol ice, exposed to radiation over eons, slowly transforming into more complex, reddish organics. This reddening is ongoing, happening now. Radiation from the sun and from cosmic rays constantly bombards Arikata's surface, slowly, patiently, altering its chemistry. In 1 billion years, Arikov will be redder than it is now. In 2 billion years, redder still. Change, slow change, but real. So the Kuiper Belt is not frozen in time. It's frozen in temperature, yes, but not in time. Things still happen. Atmospheres sublime and refreeze. Ice volcanoes erupt. Impact occur. Surfaces flow and convect. Radiation alters chemistry. Colors deepen. The pace is slow. Glacial. Slower than glacial. Even, but it's there. These worlds are not museum pieces under glass. They're active environments, still evolving, still responding to forces both external and internal. And there's something hopeful in that, something encouraging, even in the coldest, most remote places in the solar system, even where sunlight is faint and heat is scarce. Change persists, activity continues, processes run. Nothing is truly dead. Nothing is truly finished. Given enough time, even frozen nitrogen can flow. Even ancient surfaces can be renewed. You don't need much energy to create change. You don't need dramatic conditions. Even the faintest warmth, the smallest input, can drive processes if given enough time. Pluto's nitrogen glaciers flow on almost no heat at all. Arikatha's surface reddens under the faint touch of cosmic rays. Seasonal cycles happen on worlds that receive 1,000 the sunlight Earth does. Activity persists. Life, not biological life, but geological life, continues. So rest now, knowing that even stillness contains motion. Even cold contains processes. Even darkness contains change. You might feel frozen sometimes, stuck, unable to move or change or grow. But the Kuiper Belt reminds us that change happens even in the deep freeze, even where conditions seem impossible, even where nothing should move. Slow change, patient change, change measured in centuries or millennia, but change nonetheless. You don't have to transform overnight. You don't have to flow like lava. You can flow like nitrogen ice, slowly, imperceptibly, but truly. The Kuiper Belt is active, and so are you. Even in rest, even in sleep, your body repairs itself. Your mind processes and consolidates. Change happens even when you're still. So be still now. Let the slow processes run. Let the patient transformations unfold. Like Pluto's atmosphere, freezing and subliming. Like Arikatha's surface, slowly reddening. Like the nitrogen ice, slowly convecting. Active, not dead. Changing, not frozen. Alive in your own slow way. The Kuiper Belt knows this truth, has demonstrated it for billions of years. And tonight, you can rest in it. You are not stuck. You are not finished. You are not dead. You are slowly changing, slowly processing, slowly flowing towards something new, even in the deep freeze, even in the dark, especially there. Close your eyes. Feel the slow change within you. The processes you can't perceive, but that continue nonetheless. Like the Kuiper Belt, active, patient, alive. Rest now. The change continues even as you sleep. Slow change, good change, patient change, the kind that lasts, the kind that endures. Like the ice, like the color, like the surfaces renewing themselves in the outer dark. You are changing too, gently, slowly, perfectly. Sleep, the conveyor belt where comets come from. The Kuiper Belt might seem distant, disconnected from Earth, a region so far away it has nothing to do with our daily lives, our planet, our sky. But that's not quite true. The Kuiper Belt touches Earth regularly, continuously, through visitors, through messengers, through objects that begin their journeys in the outer darkness and end them streaking across our sky. Comets. You've probably seen a comet, or at least heard of them. beautiful objects with glowing heads and long, streaming tails. They appear in our skies, visible for weeks or months, then fade away, returning to the darkness. But where do they come from? Some comets, the long-period comets, come from the Oort cloud, that vast spherical shell of icy bodies surrounding the entire solar system. These comets have orbits measured in thousands or millions of years. They visit the inner solar system once, maybe twice in human history, then vanish back into the deep. But other comets, the Kuiper family comets, have shorter orbits. They return regularly, every few years, every few decades. They're familiar visitors. And these comets, these Kuiper family comets, come from the Kuiper Belt. The Kuiper Belt is their birthplace, their home, and through a slow, patient process, the Kuiper Belt sends them inward, toward us. It works like this. Most Kuiper Belt objects orbit peacefully, undisturbed. They'll remain in the belt for the entire lifetime of the solar system, billions of years more. But some are in less stable orbits, particularly in the scattered disk. Remember the scattered disk? Those objects with highly eccentric orbits, perihelia near Neptune, aphelia far beyond. These scattered disk objects occasionally pass close to Neptune, and when they do, Neptune's gravity tugs at them, perturbs them, changes their orbit slightly. Usually, this just makes their orbit more eccentric, stretches it, sends the object farther out on its next orbit. But occasionally, rarely, the perturbation sends the object inward toward the inner solar system. It doesn't happen all at once. It's a gradual process, a slow migration. The object's perihelion drops, first inside Uranus's orbit, then inside Saturn's, then inside Jupiter's. Each close pass to a giant planet adjusts the orbit a little more, nudges it, shapes it. Eventually, the object's orbit brings it close enough to the sun that its ices begin to sublime. Heat from the sun vaporizes the frozen materials on its surface. Gas streams away, carrying dust with it. A coma forms. A tail develops. The object has become a comet, visible, bright, beautiful. This comet will continue to orbit the sun, returning every few years, shedding more material each time. Eventually, centuries or millennia from now, it will exhaust its volatiles, become just a rocky core, a dead comet. But for now, it shines, and people on Earth look up and marvel. That comet began in the Kuiper Belt, perhaps billions of years ago. It orbited there, frozen and dark, until gravitational perturbations slowly, patiently, sent on a journey inward. The Kuiper Belt is a conveyor belt, slowly feeding comets into the inner solar system, one by one, generation after generation. There are transition objects, two objects partway through this journey. We call them centaurs. Centaurs orbit between Jupiter and Neptune. They're no longer in the Kuiper Belt proper, but they haven't yet become comets. They're in between, transitioning, migrating inward. Some centaurs already show cometary activity, faint halos of gas, small tails. They're beginning to sublime, beginning to transform. Others are still dormant, still frozen, but give them time. Give them a few more close passes to Jupiter or Saturn. They'll develop activity eventually. Chiron, Chariklo, Pholus, these are centaurs, former Kuiper Belt objects, future comets. Right now they're in transition, caught between worlds, between the frozen outer system and the warmer inner regions. The scattered disk is the primary source. Objects there have the eccentric orbits needed to eventually encounter the giant planets and be redirected inward. But the scattered disk itself is fed by the Kuiper Belt, by gravitational interactions, by rare collisions, by the slow ongoing evolution of orbits over billions of years. It's all connected, all part of one great cycle. The Kuiper Belt loses objects slowly, very slowly, but continuously, and those objects become centaurs, then comets, then eventually dead comet cores or dust scattered throughout the solar system. Some of that dust reaches Earth, burns up in our atmosphere, becomes meteors, shooting stars. When you see a shooting star, you're seeing dust from a comet, and that comet likely came from the Kuiper Belt. The Kuiper Belt touches Earth every night, through meteors, through dust, through the faint glow of the zodiacal light. Sunlight reflecting off cometary dust spread throughout the inner solar system. And there are odder connections still. Triton, Neptune's largest moon. Strange, unusual Triton. Triton orbits Neptune backward. Retrograde, the only large moon in the solar system with a retrograde orbit. This tells us Triton wasn't born around Neptune. It didn't form an orbit. It was captured, grabbed, pulled in from somewhere else. And where did it come from? Almost certainly the Kuiper Belt. Triton is probably a captured Kuiper Belt object, a dwarf planet-sized world that wandered too close to Neptune and was caught. Its orbit circularized over time through tidal interactions, settling into nearly circular path we see today. But it remembers its origin, its retrograde orbit, its composition similar to Pluto's, its geology active, young, with nitrogen ice and geysers erupting from its surface. Triton is a piece of the Kuiper Belt transplanted, orbiting Neptune, visible in modest telescopes from Earth. The Kuiper Belt is here, in our sky, in Neptune's system. And then there's the far frontier. Objects like Sedna. Sedna is strange. Its orbit is enormously elongated, perihelion at 76 astronomical units, aphelion at about 937 astronomical units. Sedna never comes close to Neptune, never close to any planet. Its orbit is entirely detached from the planetary system. So, how did it get there? What put Sedna on such an orbit? We don't know for certain. Perhaps a passing star billions of years ago perturbed it, perhaps a distant, undiscovered planet in the outer solar system. Perhaps something else we haven't thought of yet. But Sedna represents a transition, a boundary between the Kuiper Belt and the inner Oort cloud, between the known and the unknown. Objects like Sedna tell us there's more out there, more structure, more populations we've barely glimpsed. The conveyor belt extends farther than we've mapped, reaches deeper into dark, connects regions we're only beginning to explore. So the Kuiper Belt is not isolated, not separate. It's part of a system, part of a cycle, part of a great slow migration of icy bodies from the outer system toward the inner. And this migration touches Earth, brings us comets, brings us meteors, brings us beauty in the night sky. The next time you see a comet, the next time you see a shooting star, remember the Kuiper Belt. Remember the long journey that object took from the frozen outer reaches, through the realm of the giant planets, into the warmth and light of the inner solar system. A journey of millions of years, billions perhaps, from darkness into brief, brilliant visibility, then back to darkness again. The Kuiper Belt sends these messengers continuously, patiently. The conveyor belt never stops, and we receive them, look up at them, wonder at them. Connection across billions of miles, across billions of years. The Kuiper Belt and Earth, not separate, connected through comets, through dust, through the slow, patient migration of ice from the outer dark to the inner light. Rest with that connection now. You are not separate from the universe, not isolated. You're part of systems, part of cycles, part of flows much larger than yourself. Like the Kuiper Belt feeding comets inward, like Triton captured and transformed, like Sedna marking the boundary to something even more distant. Everything is connected, everything flows, everything migrates and transforms. You too are part of this, part of cycles, part of systems, part of the great slow movement of matter and energy through space and time. The conveyor belt runs continuously, patiently, connecting the far to the near, the frozen to the warm, the dark to the light. And you are carried too, by time, by processes, by forces larger than yourself. Let yourself be carried now into sleep, into rest, into the slow, patient darkness. The Kuiper Belt sends its messengers, and you can simply receive, simply rest, simply allow the journey to continue. Close your eyes, feel the connection, the flow, the slow migration from waking to sleep, like a comet from the Kuiper Belt, beginning in the far dark, moving slowly inward toward warmth, toward light, toward transformation. You are on that journey now, from waking to dreaming, from day to night, from activity to rest. Let the conveyor belt carry you. The Kuiper Belt knows how, has done it for billions of years, and Tonight, you can trust it. Trust the journey. Trust the flow. Trust the slow, patient migration into sleep. The comets come. The meteors fall. The dust glows. And you can simply rest. The conveyor belt continues. Always, reliably, patiently, bringing ice to light, bringing dark to day, bringing you to sleep. Let it happen. Let yourself be carried. The Kuiper Belt sends you this gift, this connection, this reminder. You are part of the flow. And tonight, the flow carries you to rest. Sleep now. The journey continues. The belt revolves. And you are home. The weird stuff, things that shouldn't be there but are. We've spoken of order, of structure, of resonances and populations and gentle formation. But the Kuiper Belt holds mysteries too, anomalies, objects that shouldn't exist, patterns that don't quite make sense, things that whisper of forces we don't yet understand, of influences we haven't identified, of secrets still hidden in the outer dark. Let's explore these mysteries now, gently, without alarm, just curiosity, wonder, the pleasant uncertainty of knowing there's more to learn. We begin with Sedna. We've mentioned it before. But Sedna is more than just distant. It's wrong. In an intriguing way. Sedna's perihelion, its closest approach to the Sun, is 76 astronomical units, far beyond Neptune, far beyond anything Neptune could have scattered it to. Neptune can't reach Sedna, can't touch it, can't have put it where it is. So, how did Sedna get there? And Sedna is not alone. There's Leliaquanua, 2012 EP 113, 2015 TG 387, and others, all with perihelia far beyond Neptune's influence, all detached, all isolated. These objects define what scientists call the Q gap. Q is the symbol for perihelion distance. And there's a gap, a range of perihelion distances where objects should be if they were scattered by Neptune but aren't. Objects cluster either closer to Neptune or much farther away. The middle range, the gap, is mysteriously empty. Why? One possibility is another planet, a distant, unseen planet. Something massive enough to gravitationally shepherd these objects, to carve the gap, to put Sedna and its cousins on their strange, detached orbits. People have called this hypothetical world Planet 9, or Planet X, or the Perturber. We haven't found it. Not yet, but these extreme orbits suggest something, some gravitational influence we haven't identified. Or maybe not a planet, maybe a passing star, billions of years ago, when the solar system was young and stars were more closely packed. A stellar flyby could have perturbed the outer Kuiper Belt, creating these strange orbits, or maybe something else entirely, something we haven't thought of. The Q gap is a mystery, a pattern demanding explanation, and we don't have the answer yet. Then there's Ammonite, officially designated 2023 KQ-14, but nicknamed Ammonite for its spiral-like properties. Ammonite has a stable orbit at 93 astronomical units from the Sun. Stable, not scattered, not highly eccentric. Just there, orbiting peacefully at a distance where objects shouldn't be stable for long. Why shouldn't it be stable? Because at that distance, passing stars and the galactic tide should perturb it, should gradually change its orbit over hundreds of millions of years. Objects that far out typically have eccentric, unstable orbits. They're scattered disk objects, transitioning to the Oort cloud. But Ammonite isn't eccentric. Its orbit is nearly circular, stable, as if it's been there undisturbed for billions of years. How? What protects it? What keeps it stable when it shouldn't be? We don't know. Not yet. It's anomalous. Interesting. A piece of the puzzle that doesn't quite fit. Now consider the orbital plane. The Kuiper Belt objects don't all orbit in exactly the same plane. There's some scatter, some inclination. That's normal. But when we map the orbital planes carefully, we find something odd. A warp, a twist. The plane of the Kuiper Belt, the average plane defined by all the objects' orbits, isn't quite aligned with the plane of planets. It's tilted, warped, slightly but measurably, and this warp seems to change with distance. Closer to Neptune, the average plane is one orientation. Farther out, it tilts, warps, twists into a different configuration. What could cause this? What could twist the orbital plane of an entire population of objects? Again, perhaps a distant planet. Its gravity could warp the plane over billions of years. Or perhaps the Kuiper Belt's own mass distribution creates this warp. Self-gravity. The combined gravitational pull of all those trillions of objects pulling on each other, creating collective effects. Or perhaps something else, something we haven't imagined. The warp is real, measured, confirmed, but unexplained. Then there's a clustering of extreme trans-Neptunian objects. When we look at the most distant objects, those with semi-major axes greater than about 250 astronomical units, we find their orbits are not randomly distributed. They cluster. Their perihelia point in similar directions. Their orbital planes are aligned, more than chance would predict. If these orbits were random, they'd point every which way. But they don't. They cluster, preferentially. Why? This clustering is one of the main pieces of evidence for Planet 9. A distant massive planet could gravitationally herd these objects, force their orbits to align, create the clustering we observe. But other explanations exist too. Perhaps observational bias. Maybe we've only found objects in certain parts of the sky because that's where we've looked most thoroughly. Or perhaps self-gravity again. The objects gravitationally affecting each other, creating collective alignment. Or perhaps, again, something else. The clustering is suggestive, intriguing, but not definitive, not yet. And finally, Consider the size distribution. When we count Kuiper Belt objects by size, we find a pattern, a power law. For every object a given size, there are many more objects half that size, and many, many more objects a quarter that size. This power law continues down to sizes we can't observe, down to boulders, pebbles, dust, which means the Kuiper Belt contains vastly more small objects than large ones. For every Pluto-sized world, there are thousands of 100-kilometer objects. For every 100-kilometer object, thousands of 10-kilometer objects. For every 10-kilometer object, thousands of kilometer-sized boulders. Most of the Kuiper Belt is invisible to us, too small to see, too dark to detect. We found thousands of Kuiper Belt objects, but there are probably trillions, tens of trillions, hundreds of trillions, all those small bodies, unseen, uncounted, drifting in the darkness. It's humbling. We think we've mapped the Kuiper Belt, but we've barely scratched the surface. We found the largest objects, the easiest ones, the brightest, but the vast majority, the overwhelming majority, remains hidden, unknown, waiting. Somewhere out there, right now, there are billions of kilometer-sized icy worlds we've never seen. We'll never see, probably too faint, too numerous to catalog individually. They're there, though, orbiting, existing, part of the population, part of the structure, invisible, but real. So the Kuiper Belt holds mysteries, anomalies, gaps that shouldn't exist, stable orbits where orbits shouldn't be stable, warps in the orbital plane, clustering of extreme objects, and a vast, mostly invisible population of small bodies, things that shouldn't be there, but are, patterns that suggest influences we haven't identified, forces we haven't measured, perhaps objects we haven't discovered. The Kuiper Belt is not fully explained, not fully understood. We have models, theories, ideas, but gaps remain. Mysteries persist. And that's good. Even the universe doesn't owe us easy answers. Doesn't have to make immediate sense. This collective mass, this massive disk, could create its own gravitational effects. Self-gravity, the combined pull of all those objects, tugging on the extreme trans-Neptunian objects, creating the alignment we observe. Computer simulations suggest this might work, might explain the clustering without requiring a distant planet, but it requires a lot of mass. More mass than we think the Kuiper Belt has based on our current surveys, which means either we're missing a lot of objects or this explanation doesn't quite work either. Then there are smaller possibilities, hints in the data, suggestions, perhaps not a 5 Earth mass planet, but something smaller, Mars-sized, or Mercury mass, something still significant, still gravitationally influential, but not as massive, not as far out. Some orbital analyses suggest there might be multiple perturbers, not just one Planet 9, but perhaps several smaller objects, a Mars mass object here, a Mercury mass object there, together creating the effects we observe. There's even something called the Planet Y proposal. Why for yet another, a different configuration, different mass, different distance, different mechanism. The details vary, the mathematics change, but the core question remains. Is there something out there we haven't found? And here's the thing. The orbits, the current orbits of Kuiper Belt objects, they don't fully make sense yet. Not completely. We can explain most of them. Neptune's migration, resonances, scattering, gentle accretion. We've built models that work pretty well. But the extreme objects, those are harder. Their orbits require something more, some additional influence, some force we haven't fully accounted for. Maybe it's Planet 9, maybe it's self-gravity, maybe it's multiple smaller objects, maybe it's a remnant influence of a stellar flyby 4 billion years ago. Maybe it's something we haven't thought of yet. The uncertainty is real. The mystery is genuine. And the answer is still out there, waiting to be discovered, or perhaps waiting to remain mysterious. Perhaps some questions don't get answered in our lifetimes. Perhaps some secrets keep themselves a little longer. And that's strangely comforting, isn't it? To know that the universe still holds surprises. That even in our own solar system, in our own cosmic backyard, there are mysteries unsolved, questions unanswered, possibilities unexplored. We've sent spacecraft to Pluto, mapped the surfaces of distant dwarf planets, found thousands of Kuiper Belt objects, and yet we might be missing a planet, a whole planet, orbiting our sun, part of our solar system, just out there, unseen. It's humbling, exciting, wonderful. The universe is larger than our knowledge. Always has been, always will be. Every answer creates new questions. Every discovery reveals new mysteries. And the Kuiper Belt, patient, ancient, mysterious Kuiper Belt, it's not done surprising us yet. Perhaps tomorrow someone will find Planet 9. Perhaps next year. Perhaps never. Perhaps the anomalies will be explained differently. Perhaps new data will point in a new direction. Perhaps we'll discover something even stranger. Something we never imagined. The future is open. The mystery is alive. The search continues. And tonight, as you drift towards sleep, you can rest with that uncertainty, that openness, that cosmic question mark hanging over the outer solar system. Is there something out there? Maybe, maybe not. Maybe something in between. The universe doesn't owe us answers on our timeline. Doesn't have to reveal itself according to our schedule. It unfolds at its own pace, reveals what it chooses, keeps secrets when it wants. And we get to wonder, get to search, get to live with the beautiful uncertainty of not knowing. Somewhere beyond Neptune, beyond the Kuiper Belt we've mapped, beyond even the scattered disk, there might be a world, a planet, massive and silent, orbiting in the deep dark, or there might not be. Both possibilities are true right now, in this moment. In quantum superposition, almost Planet 9 both exists and doesn't exist until we observe it, until we know, and until then, we wonder. Close your eyes now. Let the mystery hold you. Let the uncertainty be okay. Let the unanswered question drift in your mind like a planet in the dark. You don't need to know everything. You don't need certainty. You don't need answers. You just need rest, sleep, the gentle darkness of not knowing. The Kuiper Belt orbits on, with or without Planet 9. The extreme objects follow their strange paths. The anomalies persist. The mystery endures. And you can let it all be. Let it remain unknown. Let the universe keep its secrets tonight. Tomorrow, the search continues. Telescopes will scan. Algorithms will analyze. Scientists will calculate and wonder and search. But tonight, rest. Let the big mystery be big. Let the question remain a question. Out there, in the dark beyond the Kuiper Belt, there may be something waiting, something massive, something patient, something we haven't found yet. Or there may be nothing but darkness and ice and the slow, patient orbits of objects following Newton's laws. Both are beautiful. Both are true in their way. Both are part of the cosmic story. And you are part of that story too. A conscious being aware of the mystery, wondering about the darkness, searching for understanding, but also tired, ready to rest, ready to stop searching just for tonight. The universe will still be mysterious tomorrow. Planet 9 will still be hidden or absent. The anomalies will still puzzle and intrigue. But tonight, sleep. Let the big mystery cradle you. Let the uncertainty be a blanket. Let the unanswered question be a lullaby. Is there something out there? Maybe. And that's enough. That's perfect. That's exactly how mysteries should be. Unsolved. Waiting. Patient. Like the Kuiper Belt. Like Planet 9. Like sleep itself. Rest now. The search continues without you. The universe keeps its vigil. The mystery endures. And you are allowed to not know. Allowed to wonder. Allowed to drift away without answers. Into sleep. Into darkness. Into the beautiful uncertainty of dreams. Where anything is possible. Where planets hide in the shadows. Where the Kuiper Belt orbits forever. And you, safe in your bed, wondering and resting and finally, letting go, the big mystery remains. Out there, in the dark, and here you sleep, perfect, complete, at peace. Good night. How we study it. One spacecraft, many telescopes. We've spoken of distant worlds, of mysteries and anomalies, of gentle formation and slow change. But how do we know these things? How do we study a region so far away that light takes hours to reach it? Through patience, through ingenuity, through one brave spacecraft and many watchful telescopes. Let's explore the methods now, the tools, the ways humanity reaches out across billions of miles to touch the Kuiper Belt. We begin with New Horizons. Launched in January 2006, New Horizons is the only spacecraft humanity has ever sent specifically to explore the Kuiper Belt, the only one. Out of all the spacecraft we've built, all the missions we've flown, just this one has ventured that far with purpose. It spent 9.5 years crossing the solar system. 9.5 years of silent flight through the void, hibernating most of the time, waiting, patient. Then, in July 2015, it woke fully, approached Pluto, and for a few precious days, a few brief hours, really, it studied that distant world up close. The images it sent back changed everything. Pluto wasn't the dead, cratered ball we expected. It was alive, geologically active, beautiful beyond imagining. Mountains of water ice, as hard as rock at those temperatures. Glaciers of nitrogen, a hazy blue atmosphere. A heart-shaped plain of flowing ice. New Horizons gave us Pluto, really gave it to us. Made it real, made it a place we could see and understand and marvel at. But it didn't stop there. After Pluto, New Horizons continued, deeper into the Kuiper Belt, toward a second target. A much smaller object, Arrokoth, on January 1st, 2019, New Year's Day, it flew past Arrokoth, the most distant object ever visited by a spacecraft, the most pristine, the most primordial, and it showed us that snowman shape, those two lobes, that gentle contact binary, evidence of quiet formation, proof that not everything in the solar system was built through violence. New Horizons is still out there, still traveling, still sending back data, measuring dust, recording particle impacts, mapping the environment at the edge of the solar system. Eventually, perhaps in the 2030s, its power will fail. Its plutonium generators will decay below useful levels. It will go silent, but it will keep moving, keep traveling. In millions of years, it will drift into interstellar space, carrying its golden record, its message from Earth, its cargo of human hope and curiosity. One spacecraft, humanity's emissary to the Kuiper Belt. But most of our knowledge doesn't come from spacecraft, can't come from spacecraft. There are thousands of Kuiper Belt objects, hundreds of thousands. We can't visit them all. Instead, we watch, we observe, we use telescopes, ground-based telescopes, large ones, on mountaintops in Hawaii, in Chile, in Arizona, places where the air is thin and steady, where the seeing is good, where we can peer deep into space. The Subaru telescope in Hawaii has been particularly productive. 8.2 meters of light-gathering power, pointed at the Kuiper Belt, running surveys with names like fossil, faint objects in the solar system from Subaru, night after night, image after image, searching the darkness for moving points of light, objects so faint they're barely distinguishable from background noise. Each survey discovers dozens or hundreds of new objects, adds them to the catalog, determines their orbits, their sizes, their colors, slowly, patiently, building up a census, a population count, a map of the Kuiper Belt. Then there's Hubble, the Hubble Space Telescope, above Earth's atmosphere, above the blur and shimmer. Hubble's view is crystal clear, steady, perfect. Hubble has found hundreds of Kuiper Belt objects, measured their colors with precision, their sizes, their reflectivity. Hubble even helped select Arrokoth as New Horizons target, searching through archived images, finding candidate objects, calculating which ones New Horizons could reach. Without Hubble, we might never have visited Arrokoth, never seen that pristine contact binary, never learned what gentle formation looks like. And now there's something new coming, something powerful, something that will transform our understanding. The Vera C. Rubin Observatory, currently under construction in Chile, an 8.4-meter telescope with the widest field of view ever built for such a large instrument, designed to survey the entire visible sky every few nights, over and over, for 10 years. The Legacy Survey of Space and Time, LSSD, when it begins operations, likely in the mid-2020s, it will revolutionize Kuiper Belt science. Current estimates suggest Rubin Observatory will discover thousands of new Kuiper Belt objects. Thousands, perhaps tens of thousands. Objects too faint for current surveys, too distant, too small. Rubin will find them, catalog them, track them, build the most comprehensive map of the Kuiper Belt ever created. We'll learn the true population, the real size distribution, the full extent of the belt structure. Anomalies that seem significant now might dissolve into statistical noise, or they might become even more compelling, even more certain. Rubin might find Planet 9, or might prove it doesn't exist, or might discover something even stranger. The future of Kuiper Belt science. It's bright, it's coming, it's almost here. But even with Rubin, even with the most powerful survey telescope ever built, most of the Kuiper Belt will remain unseen. Why? Because most objects are small, too faint. Remember the power law. For every large object, there are thousands of smaller ones, and thousands more smaller still. We can see the Plutos, the Eris-sized objects, even some 100-kilometer bodies, if they're close enough and reflective enough. But the 10-kilometer objects, the 1-kilometer boulders, the house-sized chunks of ice, invisible, too faint, too numerous, beyond our reach. They're there though, trillions of them, orbiting, existing, part of the population. We know they're there from statistical models, from extrapolating the size distribution, from understanding how planetesimals form and fragment. but we can't see them directly, can't count them individually, can't map each one. The Kuiper Belt is mostly invisible, mostly unknown. We see the peaks of mountains and call it a range, but beneath the water, beneath our detection threshold, there's so much more. And that's okay. That's just how exploration works. We start with the brightest, the nearest, the easiest, and gradually, over decades and centuries, we work our way down. Better telescopes, better detectors, better methods. Each generation sees a little more, discovers a little deeper, pushes the boundary of the visible a little farther, and future generations, with telescopes we haven't imagined yet, they'll see things we can't. We'll discover populations we don't know exist. We'll answer questions we haven't thought to ask. Exploration never ends. There's always more to find, always deeper to look, always new mysteries emerging from the darkness. Rest with that now. The ongoing nature of discovery, the patience of science, the slow, steady accumulation of knowledge. New Horizons took 9.5 years to reach Pluto. The Subaru surveys have been running for decades. Hubble has been watching for 30 years. And Rubin will survey for 10 years. 10 years of patient observation. Every clear night, building up the most complete picture we've ever had. This is how we do it. How we explore the unreachable. How we study the invisible. Patience, time, careful observation. One image at a time. One object at a time. One discovery at a time. There's no rush. The Kuiper Belt isn't going anywhere. It's been there for 4.5 billion years. It will be there for billions more. We have time. We can be patient. We can let the discoveries unfold at their own pace. One spacecraft, many telescopes, countless dedicated people, all working together across years and decades to illuminate the darkness, to bring the Kuiper Belt into focus, to make the invisible visible, to transform mystery into knowledge. And you can rest now knowing this work continues, whether you're awake or asleep, whether you're paying attention or not. The telescopes watch, the spacecraft travels, the scientists analyze and calculate and discover. The work goes on, patient, steady, reliable, like the Kuiper Belt itself, orbiting, existing, waiting to be seen. Close your eyes, picture new horizons out there. Still traveling, still moving, farther every second. Picture the telescopes, pointed at the sky, gathering light, patient observers in the night. Picture Rubin Observatory, soon to open its eye, soon to begin its decade-long vigil. All of them working, all of them searching, all of them revealing. And you don't have to do anything. Don't have to search. Don't have to discover. You can simply rest. Simply be. Simply allow the exploration to continue without you. The Kuiper Belt is being studied. Right now, tonight, as you drift towards sleep, new data arrives. New objects are found. New mysteries emerge. And tomorrow, when you wake, there might be news, a new discovery, a new insight, or there might not. The work might continue quietly, patiently, without fanfare. Either way is fine. Either way, the exploration continues. One spacecraft, many telescopes, the patient work of understanding, and you, safe and warm, drifting into sleep. The Kuiper Belt watches over itself, and we watch over it. And tonight, you can let that be enough. Rest now. The telescopes are pointed. The spacecraft flies on. The future arrives slowly, and you are allowed to sleep. The exploration continues, always, patiently, beautifully, just like your breath, in and out, steady, reliable, just like the orbits, around and around, endless, patient, just like sleep itself, coming, inevitable, gentle, let it come. Let the exploration continue without you. Let yourself drift away. New horizons flies on. The telescopes watch. Reuben prepares to open its eye. And you sleep, perfect, complete, at rest. The study continues. The discovery unfolds. The mystery slowly reveals itself, and you dream. Good night. Closing. Why the Kuiper Belt matters. We've traveled far tonight, across billions of miles, across billions of years, from the cold classical belt to scattered disk objects, from Pluto's nitrogen heart to Arakatha's gentle lobes, from known structures to unsolved mysteries. And now, as our journey ends, as sleep draws near, let's ask one final question. Why does the Kuiper Belt matter? Why should we care about this distant, frozen ring of ice and rock at the edge of the solar system? The answer is beautiful, and it might help you rest. The Kuiper Belt matters because it remembers. It is a fossil record, the most complete fossil record of planet formation we have anywhere in the solar system. When we look at Earth, we see a world transformed, melted, differentiated. Its interior separated into core and mantle and crust. Its surface reshaped by plate tectonics, by erosion, by life itself. Earth has been recycled, processed, changed beyond recognition from its original state. The asteroids, too, have been altered, heated by radioactive decay, shattered by collisions. Many were once part of larger bodies that formed and then broke apart. Even comets that visit the inner solar system are changed by their journey. Baked by the sun, their surfaces transformed, their volatiles depleted. But the Kuiper Belt, the cold classical Kuiper Belt especially, it remains largely unchanged, largely pristine. Those objects are made of the same materials the planets formed from, the same ices, the same organics, the same rocky components, but they never assembled into planets, never melted, never differentiated. They just stayed, remained, preserved, When we study Kuiper Belt objects, we're studying the raw ingredients of planet formation. We're seeing what the solar system was made from, what it looked like at the beginning. This is priceless, irreplaceable. There's no other way to access this information. The Kuiper Belt is our time capsule, our window into the past, our only direct sample of the protoplanetary disk. And it explains so much. It explains where comets come from, those beautiful visitors to our skies, those harbingers and omens that transfixed our ancestors. They're not random, not supernatural. They're refugees from the Kuiper Belt, scattered inward by gravitational perturbations, messengers from the frozen edge. It explains planetary migration, the fact that the giant planets didn't form where they are now, that they moved, drifted, Neptune plowing outward, Jupiter perhaps moving inward then back out. The structure of the Kuiper Belt, its resonances, its gaps, its populations, all of this is evidence of that migration, proof that the solar system's architecture changed, evolved, settled into its current configuration over hundreds of millions of years. Without the Kuiper Belt, we might never have understood this, might never have realized that planetary systems are dynamic, that they change, that they're not static arrangements, but living, evolving structures. And the Kuiper Belt shows us something even more profound, something almost philosophical. It shows us that formation can be gentle. We tend to think of planet formation as violent, catastrophic impacts, worlds colliding, destruction and reconstruction. And that's true for the inner planets, for Earth and Mars and Venus. They were built through violence. But the Kuiper Belt whispers a different story. It says that sometimes, in the right conditions, formation can be soft, quiet, gentle, pebbles settling together, clouds collapsing slowly, objects touching and merging without shattering. This changes how we think about planet formation throughout the universe. It suggests that there might be multiple pathways, multiple methods, violent and gentle, chaotic and ordered. The universe is more diverse than we thought, more creative, more capable of surprise. And the Kuiper Belt is still hiding discoveries, still keeping secrets. Planet 9 might be out there, or something else, something we haven't imagined. The outer solar system is not finished surprising us, not finished teaching us, not finished revealing. Every few years, a new discovery, a new anomaly, a new object that challenges our understanding. Sedna, Eris, Haumea's ring, Arakatha's gentle formation, the orbital clustering, the warp and the plane, each one a gift, each one a lesson, each one a reminder that we don't know everything yet, that the universe still has more to show us. And that's why the Kuiper Belt matters most of all. Not for any practical reason, not because it affects our daily lives, but because it reminds us that mystery exists, that wonder is real, that there are still frontiers to explore. Even in our own solar system, even in our cosmic backyard, there are places we barely glimpsed, questions we've barely begun to ask. The universe is vast, and we are small, and there is so much more to discover. This is a comfort, a deep comfort. You don't have to understand everything. You don't have to solve all mysteries. You don't have to know all answers. You can rest. You can be small. You can let the universe be vast and strange and full of secrets. The Kuiper Belt has been keeping its secrets for 4.5 billion years. It can keep them a little longer. And you can keep yours too. Your uncertainties, your questions, your unknowns. It's okay not to have everything figured out. It's okay to be in the middle of the story. It's okay to rest while mysteries remain unsolved. The Kuiper Belt orbits on, patient, frozen, mysterious, full of wonders we haven't found yet, full of stories we haven't heard, and it will be there tomorrow, and the day after, and a billion days after that. You have time. We all have time. The exploration continues. The discovery unfolds. The understanding grows. Slowly, patiently, beautifully, just like sleep, just like rest, just like the gentle drift into dreams. So let go now. Let the Kuiper Belt hold its vigil. Let the mysteries remain mysterious. Let the discoveries wait for tomorrow. You've traveled far tonight, across the solar system, through time, through wonder, and now you've arrived at the end, at rest, at peace. The Kuiper Belt matters because it remembers, because it teaches, because it surprises, because it's still there, still orbiting, still waiting, and you matter too, for the same reasons. You remember, you learn, you surprise yourself and others, and you're still here, still breathing, still being. That's enough. That's everything. The Kuiper Belt has taught us this. Among its many lessons, this might be the most important. That existence itself is enough. That being is sufficient. That you don't have to be finished or perfect or fully understood. You can be in process, in formation, in the middle of your story, like the Kuiper Belt, ancient and yet still changing, frozen and yet still active, known and yet still mysterious. You are all of these things, and that's beautiful. So rest now. The Kuiper Belt orbits on without you. The universe continues its ancient dance. The mysteries remain patient and kind. And you are allowed to sleep, to drift, to dream, to let go. The edge of the solar system holds its vigil. The frozen worlds spin in the darkness. The comets begin their long journeys inward. And here, in your bed, in your room, in your small corner of this vast universe, you rest, safe, held, complete. The Kuiper Belt has shown us wonders tonight. Gentle formation, slow change, patient mysteries, ancient memories. And now it offers one final gift. Permission to rest, to be unfinished, to sleep while the universe keeps watch. Close your eyes one last time. Feel the weight of your body, the softness of your breath, the gentle pull of sleep. The Kuiper Belt is still there, billions of miles away, frozen, patient, eternal, and you are here, warm, breathing, alive, both exactly where you belong, both exactly as you should be. The outer solar system is not finished surprising us, and neither are you, but tonight you can rest. Let the Kuiper Belt keep its secrets. Let the mysteries orbit on. Let the discoveries wait. You've done enough. You've traveled far. You've wandered well. And now sleep deep, peaceful, dreamless or dream-filled, however it comes. The Kuiper Belt matters. And so, do you? Remember that as you drift away, as sleep takes you, you matter. You're part of this cosmos, this story, this wonder, and you are allowed to rest. Good night. Sleep well. The Kuiper Belt watches over the solar system, and whatever watches over you, it's there too. Patient, kind, eternal. Rest now. You are safe. You are small. You are perfect. Sleep